Hi there, this video is going to go over the questions from this worksheet, practice review sheet, that have to do with universal gravitation. And I'll do videos that talk about the other kind of topics. I thought I'd split it up though so the videos don't get too long. So first we'll do this one. The weight is 350 newtons. Mass is 45 kilograms. It's asking what the acceleration due to gravity is. So we know that force or the weight, force of gravity, is mass times acceleration due to gravity. So G is Fg divided by m. So that's 350 newtons divided by 45 kilograms. So G should be an acceleration. It's not a force. So it's 350 divided by 45, 7.78 meters per second squared. That's A. Question B is looking for the weight of the laser on Earth. So Fg equals mg. That'd be 45 kilograms. And then here on Earth, the acceleration due to gravity is 9.8 meters per second squared. So that would be 441 newtons. Mass of the planet. So now we're talking mass of the planet. Now we're getting into universal gravitation. We have this formula which says that the force of gravity is equal to the gravitational constant times the mass of one object multiplied by the mass of the other object divided by the distance between those two objects squared. And we want to know what the mass of the planet is. So we're looking for one of these masses. So we'll use the same data information we're given. The force of gravity is 350 newtons and the mass of one object is 45 kilograms. And we're told that the separation between these is basically the radius. That's the planet, and here's our gun. The center of one object to the center of the other is essentially the radius of that planet. Keep in mind that the radius we're given is kilometers, and we have to do all our calculations in meters. So let's go ahead and do that. I'm going to rearrange the equation to solve for one of the masses. So m2 equals Fg times r squared divided by g times mass 1. So that is 350 newtons. 8900 times 10 to the 3 meters, that's squared, divided by 6.67 times 10 to the negative 11 times 45 kilograms. So let's put that in my calculator here. So 350, enter. And I'll square that, multiply it, divide by that, and divide by that, and I get 9.24 times 10 to the 24. Kilograms. Alright. Oh, and then finally find the height above the planet's surface at which the laser weighs 300 newtons. So I'll sketch what that would look like. So this situation is, here's a planet, it's some height above the planet, call that x, some height x, that's r. So if we say h equals r plus x, we want to know what that separation is, this total h, that would make the weight 300 newtons. So if we take our same formula, this time we're going to solve that formula for r squared, or for r. Actually, in my notes here I'm calling that h squared, and h is equal to this plus this. That total thing is the, you know, even though the formula says r's is the symbol. I'm just replacing that r with, I'm saying the separation between those two things, I'm just calling it h. So I'm going to say h equals g m1 m2 divided by fg square root it all, because to solve for h we have to take the square root of everything. So h equals 6.67 times 10 to the negative 11, 45 kilograms, 9.24 times 10 to the 24 kilograms, divided by 300 newtons, and take the square root of that. Alright, so I still have that number in my calculator, which is nice. So times that by 45, times it by that, divided by 300, take the square root, and I get 9.613 times 10 to the 6 meters. And then I'll subtract the 8900 to get the r. So this total thing here is that number, 9.6 times 10 to the 6. So to get that height x, I'm going to subtract the r. So I get 713 kilometers. Alright, so that's the first gravitational question. I'll try this one too then. So it's a 100 kilogram man who weighs 6.25 newtons on the surface of Ganymede. That's right. Oh, 625. So G is equal to Fg divided by m, so that's just 6.25 meters per second squared. And what is the mass of someone who weighs 495 newtons on Ganymede? So mass equals Fg divided by G. Sorry, what was it? 495. Oops. 79.2 kilograms. So that's a pretty straightforward question, that one.